And notice that this one has one less oxygen. And whenever there is one less oxygen, we change that ATE to ITE. So this becomes sulfide ion. Here's another example of chlorine with 3 oxygen ion. A common name for this one is chlorate. So chlorate ion. Oops, sorry. Chlorate ion. So as I mentioned earlier, subtracting one oxygen from this common name ATE, you change the ATE to ITE, so chloride here, ClO2 minus, so we subtracted one oxygen, and we call this chloride ion. Whenever we add another oxygen, we add a prefix per, so per goes here, it says perchlorate ion, so ClO4 minus, so we added one extra oxygen, keeping the charge same. This becomes per chlorate ion. We can actually subtract one more oxygen from this chloride ion, so we can continue here. So minus one more oxygen, and this becomes ClO minus. We call this hypo. We put a prefix over right next to this one, and we call it hypochlorite ion. So hypochlorite ion. So notice the prefixes here and here. This is per, adding one, and this is hypo, um, taking one oxygen, subtracting one oxygen. There's one thing to mention about the oxyanions, polyatomic ions containing oxygen, is that if we focus on period 2 and 3, which is this period and this period, notice that period 2, the maximum oxygen it can have is 3, and period 4, the maximum oxygen it can have is 4. As you can see here, perchlorate ion, sulfate, and phosphate. These are most common, and like I mentioned, period 2 can have maximum of 3. Is a nitrate ion and a carbonate ion. Also notice that the charges increase from right to left. Here's perchlorate, 1 minus, sulfate, 2 minus, and phosphate, 3 minus. The trend goes from right to left, and the charge increases, the negative charge, minus charge. So we can have a situation where we add a hydrogen to a oxyanion. For example, we have a chlorate here, and then we added a hydrogen uh, into this molecule. And whenever you have this situation, if you see one hydrogen, the name starts with hydrogen. If there's two hydrogens, like in this case right here, you call it dihydrogen. So we started with chlorate ion, rate ion, and then we added a hydrogen, so we call this hydrogen chlorate. This is how we name this one. And here, a common name for this one is phosphate ion. And here, two hydrogens are added, and we call this dihydrogen phosphate. Phosphate ion. All right, so now that we know this information, we can start naming ionic compounds. So whenever you want to name ionic compounds, you start naming the cation and then followed by the anion name. As you can see, this compound is made with calcium and chlorine. Remember that calcium is a transition metal, and we have to show its charge with Roman numerals. And chlorine, we know it's always -1 charge because it's in group 7 A. So how do we know how do we know the charge of this calcium? Well, if we break this down, so we don't know the charge of calcium, right? But we know the charge of chlorine, right? Chlorine is minus. In this case, we have two chlorines neutralizing this compound. Neutralizing meaning there's no charge. So we have two of them. So we must have 2 plus 2 charge calcium, right? In order to neutralize this compound. So we call this ionic compound. We always start with the cation, so the cation is calcium. So calcium, we need the charge number because this is a transition metal. So this is 2, and we're dealing with chlorine and anions name end with IDE, so chloride, right? So calcium chloride. Here we have aluminum with a nitrate uh, ionic compound. So we know that aluminum is plus 3 charge and a sodium is -1 charge. So we name this like this: aluminum nitrate. Nitrate. So this is aluminum nitrate, and we don't need to specify the charges because aluminum is not a transition metal. We actually know its charge is plus 3. Copper, we don't know its charge because it's a transition metal, but we know the chlorate perchlorate charge. So copper, sorry, we don't know its charge, but we know the charge of perchlorate for its minus, right? So this in perchlorate is in parentheses, and we're specified that there's 2 of them. So there's 2. So in order to neutralize this compound, we should have plus 2 charge copper. Plus 2 charge. So the way we name this, we need to specify the copper charge with Roman numeral. So copper 2 perchlorate. So naming acids. To name an acid, the um, anion ending IDE changes into IC, so IC. IDE becomes IC, and the prefix always starts with hydro and always ends with the word acid. So, for example, here we had chloride, so the IDE here becomes IC, so chloric. Let's do that. Let's write that down. Uh, Chloric. And the prefix is hydro, so hydrochloric acid. So whenever we deal with acids, just remember that there's water involved. Why do I say that? Is because uh, HCl here can also be named hydrogen chloride, since I specified in the beginning that we're going to name acids. We're assuming that water is involved here as well. All right, here I have a sulfide. So again, the ending IDE becomes ic, prefix hydro, and ending acid. So hydrosulfuric acid. This is how we name H2S, hydrosulfuric acid. So remember those anions, oxy anions with different number of oxygens. Uh, Similar situation, the ending ATE or ITE changes. So ATE becomes IC and ITE becomes OUS. So again, we keep the prefix hydroperchloric acid, and then ending always ends with acid. Here, hydrochloric, common acid, and this one, hydrochlorous acid. So ITE becomes OUS, hydrochlorous acid, and hypochlorous acid.